Yeah, good morning. Back here with a lesson. That is in a last class, as I told you that today we will discuss the lab program of an NS2 where we stopped at program number 1 and program number 2. So as I will conclude you that what we have did in a previous lab programs, that is NS2 and NS1. Now, as you know that we are using the NSG 2.1 version, which is an GUI, a graphic user interface to create an TCL script. According to program number 1, we have taken 3 nodes and we have taken 0th node and 1 node and 2 node, and we made a 0th node as a source and the second node as a destination. So then in between whatever the N1 node is there, that we have treated as an in-between node, that as a router. And we have fixed the bandwidth of N0 to N1 and N1 to N2. We made a little small bandwidth and we have calculated how many packets will drop at N1 due to the congestion, and that is the capacity, the queue capacity of that N1 will be filled up, then packets will keep on dropping. Why? Because we have taken an example of 500 MB bandwidth and we have passing in just 1 MB of a bandwidth, then it's a lot of difference will be there. So that we have seen in a program number 1. And we have simulated that and I have shown you how packets will drop at N1, and varying that for 3 times we have calculated the number of the packets it has been dropped. Coming to the next program, that is program number 2. Here no evaluation is there in this particular program. They have told very clearly in a program number 2 that we should consider the 5 nodes starting from N0 to N4. So where N4 should be a middle node and all the connections should pass with a N4 as a star topology. So where N0 is connected to N4, and from N4 where it has been connected to N3. So where it is a TCP connection we have seen, and then N1 to N2 where we have seen it is as an UDP connection, and I have told you how to connect the TCP and the UDP agents. And for a TCP agent, the destination agent is an TCP sync, and for an UDP agent, a transport agent, the destination agent is a null that we had discussed, and we should connect virtually. That also I have told you. And afterwards, we should go with an source, and at a source side, we should go with what is the application agent you are going to use. As we have seen that for the TCP traffic, that's an agent, traffic agent, the FTP application agent is needed, and for UDP traffic agent, CBR is needed. And a packet size will be set in a TCP at TCP traffic agent level, but in UDP, the packet size will be set at CBR, where a packet interval, packet rate, and packet size will be set, which we have seen in a program number 2. Now we'll step into the next program, that is a program number 3, and we'll see how this program number 3 will work in that. And next we'll try with program number 4 also. First, I'll share the VMware. Later on, we'll move with the things. So I'll share this. Yeah, back. Share this. Right. Now, just yeah, manual is already opened here. Go to the manual. Program number 2 we have solved. We'll go with, sorry. Yeah, program number 3. Now see here, what is a program number 3? Simulate to study a transmission of packets over Ethernet LAN and determine the number of packets dropped at a destination, dropped at a destination. The number of packets dropped at destination. Underline that the number of packets dropped at destination. So we have to calculate the number of packets dropped at destination only always. Next, coming to the simulator to study the transmission of a packets over a Ethernet LAN. How a Ethernet LAN you can define in a NS2. So this is another one important concept which you have to take into the consideration. As usual, just just two things. 1 minute. I have taken two connections here. TCP 0, ACP agent is there. Connected TCP to TCP sync. The Windows is not needed here. N2 they have taken two separate nodes. Okay. Taking N2, N5. Two traffics they have taken. Go back to the program here. Simulate to study a transmission of a packets over Ethernet LAN and determine the number of packets dropped at a destination. So one flow is enough. Why they have made two flows that I have just it will be two flows only. They have taken two, but they have taken the same flows. Okay, let it be. Now back here with the program, we'll do some slight changes for this time in our thing and this one. So one thing, as I told you that we can use NSG here, right? So while using an NSG, you must be very careful here. You must open with Java, right? We are opening with Java. It has been opened, and as I told you that you should go with a scenario. This is wired scenario, right? But here, what is the problem? You can't create a LAN connections. So to define an LAN connection, it is very difficult here. So how you are going to do a LAN connection and how you can do the remaining things and all, I'll tell you. Don't worry about that things. First, we'll create a nodes. So how many nodes are there? We need a 6 nodes, right? So I'm creating like this. This is node number 1. Then I'll create node number N1. Then I'll create somewhere like this. Number 2, node number 3, node number 4, and node number 5, and node number 6. Let it be. Don't create any links and all here. Why? Because we need to create the LAN connection there. So duplex links and all will not be possible. So what you have to do, you directly go to the agent. So now you define source and destination. I'm making an easy part of you. Only one line you have to type of a LAN. that I will tell you. So go to this. So first TCP connection will be defined from node 0, let it be, that's a TCP 0, and according to us the destination node here which we are going to take, let it be TCP sync always, we know that. So that will be node 6 here which we are taking into the consideration. So we have to connect from the TCP to sync, the virtual connection which we have did. Right. Now coming to the next step, that is the application. For TCP, the application is FTP, as we know already. So just drag this from there, as I told you. So drop there. So it should start at 0.0 and it should end at, will take 25 seconds. So I will make it as 24.8, right? So that's another one thing. Let it be. Now we'll take another connection also, and at the destination we have to check how many packets has been dropped. So that we are going to take into the considerations. So either you can take a single connection, or either you can take a double connections. That is left to you. Right. So to make your LAN busy with the things, I'll take another connection also. So we'll go with agent again. So I will take UDP here, right? So click on N1, drag it. I'll drag like this. Yes. So UDP is ready, and if UDP is there, I'll take N5 as a destination. So UDP means the destination. At the destination, null must be there. So I'm taking that null. So virtually I'm connecting UDP to the null connected. Once UDP is there at application, I need a CBR. So go to the application type and take a CBR. Here 0.0 to 24.8, which we have taken. Okay. Packet size still you want, you can reduce this. So I'll make a packet size as 500, and the rate whatever is there, let it be 1, and interval let it be this. Okay, not an issues for us. Jen, you connected this, right? So now everything is ready, but we have not connected nodes 1 to 1. So go to the parameters here, and you can take this into the consideration, that is 25, and back here, that is proc 3 dot tr, then prog 3 dot nav. So done. Now what you have to do, just you generate a TCL script. Hey, generate TCL scripts. Okay, once you have generated a TCL script, and you can see now here what we have did, one particular thing we have left it out. What is that? A node to node connection, we had left it out. That you have to keep in your mind. Why? Because LAN you can't do in a NSG, as I told, and manually you have to enter that particular statement. Now just tell save. Now back here I'll tell prog 3 dot, or you can take a program also, not anything. Program 3 dot TCL. Now type enter. Once you have typed enter, now it has been saved already. Then close this, and close this particular thing, right? Close this also. Yeah. Now go back to the terminal, as we have did in for a last program also. So now you make it gedit program 3 dot TCL. Now open this. Still you can't run this program. Keep in your mind why you can't run this particular program means no connection is there. If you want, you can check it out. Set val stop 25.0. Everything other things is there. So NS as a simulator. Now the output file, two output files is there. Prog3.tr, prog3.nam is there here, and number of nodes which we have created. Everything is there. That is up to N6. N0 to N6, everything is there. So links, creating a links is not there here. So now you have to create a LAN connections. How you have to create a LAN connection? For that, a single statement will be there. Entire for an entire program, that is a heart of this particular program. That's why you have to keep remember that particular lines always. Otherwise, you can't do the things. Why? Because in NSG also you can't implement LAN. Because of this statement plays a very much important role. Now, coming to here, you can see this particular statement here. Yeah, right? LAN physical layer word. Right. What is that? $NS in the simulation NS make LAN is a command. Make -LAN is a command. After that, you have to define how, within a quotes how many nodes you want. But that node should be created already. That you have to keep in your mind. So we have created a nodes. Sorry, we have created a nodes N0 to N6. So that's why I'm taking dollar of N0. If you take only N0, that's the characters. As in a TCL, I've told very clearly. So dollar of N0 means it's an object now, means it's a node now. So N0, no comma, only space, dollar of N1, N2, N3, that taking this all six nodes into the consideration, you make a LAN taking six nodes into consideration with bandwidth of 100 MB and 1 millisecond delay and the queue length, whatever a queue length, LL, queue length, the queue in a queue length, the Q, capital letter Q is important here. If you type a small letter Q, it's an error again. So capital letter Q slash drop tail. What Q you want? Drop tail Q we need. And a MAC layer, so MAC, M capital letter, MAC slash 802_3. This indicates Ethernet. In a problem, they have asked it very clearly. We have to create an Ethernet LAN. So to create an Ethernet LAN, the Ethernet LAN will work 2.3 the protocol. So here we are representing 802_3. That's the protocol which we are going to use in a MAC. So then what the channel is here, physical channel is here. Channel is a physical. So P capital letter, C capital letter here. Channel space, which channel that is? Channel is PHY physical slash wired physical layer. It's not a wireless, it's a wired. So W capital and a P capital. So this is very much important. Wherever a capital letters, it's a very case sensitive. So this entire statement you have to learn on your own for this entire program. So NSG will be there. In NSG you can create remaining things. But to create a LAN, this is a very much important thing. Now you can save this. Now connections as you have did with a LAN. What is our intention now? From N0 to N6, we are sending TCP packets. From N1 to N5, we are sending a UDP packets in the same LAN. So then the bandwidth of 100 MB will be utilized there. So now what is the intention here? We have to calculate how many packets it has been dropped at a destination. So that is a full program completion. Now save this particular program, close this. Yeah, just I'll put it on a taskbar. Yeah, now you run this. That is NS space program 3.tcl. Now run this. Yeah, it's came. Now observe, I'll explain you the LAN, how it will be there, which you have seen theoretically. Also, I explained you, and in lab example we have taken, and we have did that particular thing. And you can see here, while discussing Ethernet also, I told very clearly, 0 is there, I'll take 1 this time, and 2 that side, and again 3 I'll take this side, even numbers and all. I will take 4 that side, and I will take 5 this side. Yes, and I will take 6 that side. Good. Now observe carefully. I'll back to the view mode. And now observe carefully here. Whatever a lane you are seeing here and all the systems are a nodes which is connected to the same line. Observe in our lab we are having one switch, one hub is there. To that particular switch and hub, all other nodes are been connected. If you want to communicate within this particular LAN, the packet will be sent to the switch here, and from the switch the packet will be bounced back to all other nodes. This is very much important. The packet will go to all other nodes. Yes, it will go. It will goes to all other nodes. And if the packet related to that particular node, then it will take inside. Otherwise, it will drop the packet. This is the working nature of an Ethernet LAN. I repeat once again. What theoretically we have studied, observe carefully. Now this will become another hub here, counted hub here. So this is 7. In a trace file, if you want, I will show. This is a 7 here. So if you take this node as an S7 or switch as an S7, so all the nodes, whatever you have defined from 0 to 6, that is 7 nodes. Assume these are 7 systems which has been connected to this particular hub, to the ports, right? So this, whatever is there, this switch will work with 100 Mbps bandwidth and 1 millisecond, and wired connections will be there in this. Whatever a LAN statement you have defined, that LAN statement is made to this particular switch, which is called in a number called as a 7 in a 0 to 7 series. So that is very much important, which you should know. Now, according to us, we know that 0 to 6 we are sending a packets, and as well as 1 to 5 we are sending a packets. So just I'll click on this. If you want, you can make a color also. If you want to make a color, I have told you that how you can differentiate two colors. Okay, we'll make a color and we'll come back again and we can do it. Otherwise, both will be looked in a black color. Either way, you can do the things, not on a issues. So now I'll run, we'll see. All right. Started. From 6, reply is coming. From 5, no reply is there. You can see there's a UDP. So to make you know this, it's going to all. Seeing there what I have told you, that is the thing. That is the thing. From 1 you can see there's a UDP packet which is going to all other nodes, and only 5 will take that, and remaining will drop that particular packets. It depends on a version of what the system or a VMware or means Fedora you are using, where the packets drop will not be shown, but in trace file it will be shown very clearly. Don't worry about that. In animation, this is a things which you should watch very clearly, as if I will make a faster things, just still faster. Why TCP is not going, only UDP is working out? That's my doubt. Only that I am saying. When I stop at that, we'll check a code once again. Yes, already is going. Yeah, we'll check it out once again. Our code, not any issues. Stop time of FTP we'll check. Maybe it's worked, but it stopped. All right, close this. Now go back to the program. See, go back to the program. Yeah. Now you can check, come back to the FTP. Yes. See, stop time, it's stopping at 2. That's a mistake which we have did. Come back again. See here 24.8 CBR and observe carefully it's starting at 1 and completing at 2. No, our intention is it should also start at same time. 24, just I'll make, let it be started. 24.5, somewhat earlier than UDP. Now this will be done. So that's a one change which we have to do, and I have told you about the colors. So now we'll implement that color also. So come back here, as I told you that dollar NS in that color. So what a color you want to use? One for I'll take red, right? And dollar NS color. Two I'll take for blue, right? So it has been defined. Color has been defined. I have to use 1 and 2 there. TCP and UDP. Now come back to TCP. As I told you that before attaching only, you can tell not an issues. Here dollar TCP 0 in that set class variable underscore indicates the reserved variable. What's the value? TCP I want a blue, then it will be 2. Then come back to UDP here. Now dollar what is there UDP 2. So dollar UDP 2 in that set what variable? Class variable underscore indicates reserved variable as 1. Now save this. Now you can run again this particular program, which is there according to the frame is too big. It's telling 1554. Yeah. Now back here you can arrange it. Not other things you can arrange clearly, and you can show to the examiner or yourself. You can see very clearly. 0 is there, and same thing. Even in the odd I will make year and day. That's it. So sorry, to that side I think. 2, 3, 4, 5, yeah, 5, and coming for 6. I think that if you want still the things 6, that's what it should be like that. That's what I said. And that if you want to still to try this, right, that looks still better. But now you can see from 0 it's going at the TCP, it's working. You see both. Yeah. TCP also it's sending to all other nodes. The 6 will take other packets, other nodes will drop. This is the way the Ethernet will work, and even you can see a UDP which is going from 1 is moving to all the nodes. Later on, 5 will take that, and remaining will be dropped. So in this way, you can take this snapshot and you can implement, means you can put it in a record. So in this way, the third program will be working. Now another part is there of a program that we have to evaluate how many packets has been dropped at a destination. Then I will make it as a fast this one. Just so just animation is just to show the end user that how the packets is moving. Just showing for a showing purpose of packets how it will move. We are using this NAM animate. So that's a one thing. Done. Now we'll go back. Control C, come out from the program. Now, first gedit will observe the trace file. If the trace file is there or not, first you check it once. Ls see prog3.tr is there. Yes. Send gedit prog3.tr. So press enter. Right now it is there. Now you observe carefully here what wherever h indicates the hub, h indicates hub or a switch. So it's a new thing which is there in a first column. In the beginning I have told you that plus indicates NQ, minus indicates DQ, and R indicates receiver node, and D indicates a drop. But here H will be there in always LAN connections that will indicate the hub. Now observe carefully here. Though whatever is there here, this is a time second column, and this is a source and this is a destination. From 0 to 7, it is coming. 0 to 7. Where is 7? We have made N0 to N6 only. But what is this 7? As I told you that 7 is a hub switch, which you are going to create as a LAN. Right, so that you have to take into the considerations. Now what is a program means to show this particular thing, the extra lines whatever is it to show that I'm showing this particular file here. Now see, CBR packet size is 500 is there, and wherever you go TCP you can see here 1540 is there. Why? Because 1500 we defined the packet size and 40 will be the header size, which you know already, which we have discussed in a theory. Now here in this particular tracing lines, you can see how many maximum tracing lines it has been done automatically. According to me, it is of 64,000. Am I right? 6,44,824th line. So 6,44,000 approximately, that many lines of code means that many lines of tracing lines it has been taken into the consideration. Out of this, searching the dropped packets or deep packets, it's somewhat difficult. For that, we'll go for an AWK program and we'll filter from this particular file, that is tr file. Now back here, right, and we'll go with an AWK script, that is gedit program 3.awk. Enter. Now what is a program? I'll take here from a manual, right? The slight changes we have to do, we'll do automations. Yeah, from here the AWK script will start. I think to C. Right. Go back to the program. Yeah. Right. Now observe the program here. Simple. It's very simple. How many packets has been dropped, that we are going to take into the consideration. Here, begin count. I am initializing as a variable count 0. If $1, whatever is there is equal to D, just you increment the count variable. That packet has been dropped. That we are going to consider. Number of packets dropped, which we are going to take at that particular thing. But here, see the things what I mean to tell you. That is, two destinations will be there. Correct? No, means always in a program they have given how many packets has been dropped at a destination. So here two destinations is there, which destination we should take and what count we should take. So that is a one important thing which we should take into the consideration. That is, here it will display both at UDP as well as TCP. It will display both destinations how many packets has been dropped. They have asked very clearly at a destination how many packets dropped. We are telling at a destination this many packets dropped. So we are not distinguishing here, that is TCP this many dropped or UDP this many dropped. We are telling at a destination, both the destinations this many packets has been dropped. First we'll see this, how this particular program will work. Later on we'll look in depth for that. Now should say, so AWK space option F. So program will be there from input will be given from a file, so that's why F AWK, then input file is prog3.tr, that we know, right? Number of packets dropped is 0. Your destination never missed any packets there. So how to miss packets if you want to show or something like that, then you have to reduce the bandwidth of your LAN. That's it. Your LAN of 100 Mbps is capable with 6 nodes, means 100 Mbps utilizing itself will be a difficult task. You can imagine. So in our lab, we are having a 30 systems and just we are having the switch of, I can say 10 Mbps. So imagine, so 6 nodes with 100 Mbps means where packets will drop. No, never drops. So according to me, I will change the bandwidth of that. So I'll go program number 3. Switch bandwidth means I'll make LAN, whatever is here, I'll come. So here, instead of 100, I'll go with first 10 MB, I'll say this. Close this. Again, you have to do the process. Means again, you have to run TCL script. 1 minute. Yeah. So again, you have to run a TCL script here. Exits dropping packet. Now it will show. Good. See now, just I'll run this arrangements and all. I've shown you once. Right. So both it's working. If you want to see both, just slow down this. Yeah, you can see like this. Just I'll faster the things. Okay, done. Then close this. Now Control C. Now back here, you run a AWK script. Yeah. 209 packets has been dropped. Imagine now. See, out of these two traffics, which you can take into the when either I have kept in 100 Mbps, 0 packets has been dropped. When I reduce to the 10 Mbps, then automatically 209 packets has been dropped. Then you can imagine the capacity of the Ethernet will be there on bandwidth. That is what bandwidth you are going to take. In market also, if you go and if you ask for Ethernet switch, they will ask you what Mbps or what giga. It's there in gigabits also. They will ask you. If you ask 1 gigabit bits per second switch I need, then automatically it will be a costlier one comparative to the lower bandwidth. So like that, even in a market, it will be like that. Now I've shown you a live example that when you take 100 Mbps, performance will be very good, where no packet will drop. When you will take Ethernet switch of 10 Mbps, 209 has been dropped. So you can cross verify, you make your LAN bandwidth as 50 Mbps. Now again you check. So according to that, maybe again drop will be there. So like this, we'll evaluate for my 6 systems. I assume that I am going for a cyber, I am opening a cyber center and I want a switch here. Before opening a cyber, so once I brought a switch, so it will be not frequently, which will be changeable. So for that, what I should do before going for that, I should solve the problem in a NS. Assume I'm going for a 10 systems of LAN will be there for me. 10 systems LAN if I want to do for my cyber CAF. assume another 5 also I will add up. I'll go for a 16 port switch. What should be the capacity? This much bandwidth I'm getting from a server, so the distribution should be there with an eventually. Then how you should do the things? Then what is the switch capacity you need? To solve that, if you solve this particular problem, then automatically you are going to get. So which type of which bandwidth type of a switch will be needed for you, you will get automatically. That's the advantage of this lab programs which is there, and NS2 also you can simulate like this, and you can then go for a practical purchase of the devices. So that is your program number 3. Coming to the next program. So next program in tomorrow class I will teach you next program, that is program number 4. So 4 programs will be completed in part B also, part 4 programs. Another 2 programs will be remaining. So later on we'll do. But tomorrow class will also have the lab program, right? Um, Now just I'll stop this sharing. 1 minute. Stop sharing. Now just I'll go back to the video. Yeah, back here. So I think you have followed the instructions what I given for an program 3, a lab program. How you can create a LAN in a NS2 of for 7 systems which will be connected to a hub, and you have evaluated based on a bandwidth how many packets will be dropped at a destination. So we have seen that at a destination, 209 packets will drop. It's a 10 Mbps. If it's 100 Mbps, 0 packets has been dropped. Now in tomorrow class, we'll go with program number 4, and we'll see how a multicast program, means multicast routing, will be working, and how it will work. We'll see that. Thank you very much. Thank you.
Thank you. Thank you, sir.